So why you know that we wanted to study functions because those are the objects that we're working with in calculus. And now I've spent some time talking about interval notation. There must be some reason why. The reason why is we want to get good at describing domains. Range is a lot more difficult to describe, so I meant to delete this, but I forgot somehow. So you could scratch out that range part. Okay. So in general, there are two things that can go wrong. Does anyone know what the two things that can go wrong are as far as the domain of a function goes? Anyone have any feeling?
Isn't it something like when you factor it, it's like the denominator of it's zero or something like
That's
that?
the first one. Yes, yes, good. The first one is the denominator is equal to zero. So I'm going to say we can't have zero in the denominator. Okay, for sure. Great, Catherine. Um, there's another one that involves radicals. Does anyone remember what the thing that can go wrong involving radicals?
Asymptotes?
Asymptotes. Asymptotes actually correspond to the zero in the denominator. So like if you have a function like f of x is equal to 1 over x, do you see how when x is equal to 0, you're going to have a 0 in the denominator? So then when you go to graph this guy, it kind of looks like this. And then you actually have an asymptote at x equal to 0. So you are correct, but we already talked about that.
Is it if the I think it's the radicand is negative?
Almost, yes, almost. I want to say yes. Let me ask you this. If we have something like this, is there an issue?
No.
No. So what is it also, in addition to the radicand being negative, what is it that we also care about?
That thing, I don't remember what it's called.
Yeah,
Even?
yeah, that's called the index. That's called the index.
There you go.
Yes. So you can't have negatives inside of an even indexed root. Okay. So I'm slightly worried that you are not sure what I'm talking about, so maybe I'll try to explain a little bit more. You know, something simple, if we have something like g of x equal to the square root of x, that's an even indexed root. So we want to make sure that x is greater than or equal to 0. Remember, it has to be non-negative. Doesn't have to be positive because we still allow 0. Okay. You may or may not know that when we write it like this, the index is assumed to be 2. So what we could do is we could really write this as this is the same thing as x is equal to 1 over 2. So this is, you guys probably know this already, but I just want to make sure we're speaking the same language. This is called radical notation. It's like it's radical, man. This is called exponential form. Exponential form. Guess which one we like better in this class? Does anyone have a guess? We like exponential form better. It's not clear to you why, but we do. So I want to make sure that we're all on the same wavelength here. So let me just talk a little bit more about this. Let's have h of x. Let's have h of x is equal to something like this. If I wanted to write that in exponential form, how would I do that?
1
or the
over
power
3.
root. Correct. 1 over 3.
X to the 1
Yes,
over 3 power.
that's right. X to the 1 over 3. Excellent. What if I wanted to write j of x equal to 1 over the 5th root of x like this? How would you write that in exponential form?
J of x is equal to 1 over x to the 1/5 power.
I want to
X to
write it
the-
as just, go ahead, say it.
X to the power minus 1 over 5.
Right. So your answer was correct earlier, but I didn't want it the 1 over. I want to get rid of the 1 over. I want to just write it as x to some power. Okay, let's do one final one. I think you guys get the idea, but just if I can clear this up now, then it'll make our lives in the future easier. So what if I have something like this? How does that look?
X to the power 3 over 4.
Correct. I'm going to write another step here, if you don't mind. I'm going to write this as x cubed is the inside, and then the 4th root is to the 1/4 power. So what you end up with is you end up with a power to a power. And as you know, when we have a power to a power, you multiply those powers together. So this is x to the 3/4, as was suggested. Okay. So let's say you wanted to find the domain of this. Does anyone have an answer for part A here? What do you think the domain is and why? Let's say you didn't know how to start. You know, you're like, Dr. Yang, I understood everything you said, but when you ask that question, I don't know how to start. Well, what did I just say? I just said, oh, there's only 2 things that can go wrong. Do we have a 0 in the denominator? In this case, there is no denominator. It's not an issue. Second question, do we have a negative under an even indexed root? There are no square roots here, so nothing can go wrong. So when nothing can go wrong, the domain is going to be all the real numbers, right? So how do we describe all the real numbers? You can do it in a variety of ways. You can have wait, my alarm was supposed to go off, right? Oh no, not yet. So we could say the domain is all real numbers. That's like how little kids write it. Pros go negative infinity to positive infinity. That's sort of like, I think, how we should write it. You could write it as all real numbers like this. That's the way that lazy people write it. And you could write set builder notation. That's like x, such that x is a real number. That's like the fancy show off way to write it. Make sense? All right. No questions, right? Cool. What do you guys think about B? What do you notice?
There's a radical sign?
We have a radical. So I think when we have a radical, we want to make sure that we don't end up with negatives under the radical, right? So what we need to do is we need to take the inside and we need to make it to be greater than or equal to 0. You guys know what the square root of 0 is? 0, right? So, okay, so we need to solve this inequality. So maybe I should have said that. So what are we gonna do? I think the first thing we should do is we subtract 3 from both sides because we're trying to isolate the x variable. So this will give you 2x is greater than or equal to -3. And then we're going to divide both sides by 2. So we're going to get x is greater than or equal to -3/2. And that's going to be our answer. Why don't we write this as in interval notation? So it says the smallest number is -3/2. We want to include it, so we put the square bracket, and we want all the numbers that are bigger than that. So we want to go all the way out to infinity. In this class, I think it's best for us to put a sign on our infinity because infinity goes in both directions. So this is positive infinity and it's negative infinity. Okay, so this is our answer. Is there any questions about this? Oops. All right. So hold on one second. Let me switch the captioners here. Let's see, how do I do that? Where are the people? Dana, there's Kate. All right. Cool. So any questions so far? You know, we have classwork planned, but I'm just going to ask you right now. I just want you to try one. So why don't you guys try this one? F of x is equal to the square root of 3 minus 2x. Why don't you figure this out and then type your answer in the chat box when you finish. I see a variety of answers here. I see 2 main answers. All right, good. Well, I'm definitely glad I asked you because, okay. So let's go over this. We get 3 minus 2x, and you want it to be non-negative, so that means greater than or equal to 0. And I can see there's a couple ways to do this. I'm going to do it like this. The first thing I do is I'm going to subtract 3 from both sides. If you didn't do it this way, that's great, but I'm doing it this way to illustrate a point. And then when we do that, you get 2x is greater than or equal to -3, right? Sorry, -2x, like this. And then the next thing we need to do is we need to divide both sides by -2.
Professor, we can't see what you're writing.
Yeah, I can see it.
Okay. Is there anyone that can't see it? All right. So, dang, I sort of led right up to the main point and then I got ruined here. So I'll start over. The last thing I said was we got to divide both sides by -2. What's the deal here? when you divide by a negative number, what would you need to remember? Yeah, you got to invert the inequality. So it becomes this. Does everyone see that? So, so then this means that this is saying that the biggest the x value can be is 3/2, and we want to include it. And then the smallest it can be, well, we can go to -infinity. So I think it's going to look something like that. Does that make sense to everybody? Any questions? All right. If we look at C over here, what's the deal with this guy? I can see that we're going to have a 0 in the denominator. So we have a denominator. So we simply set that denominator equal to 0. 3 minus x equal to 0. That means 3 is equal to x. But we don't want it to equal to 0, so we put not equal to there. Okay. So I want to describe all of those numbers. So how do we describe all these numbers? Well, if you were to say it in words, you'd say, I want all the real numbers except 3. You'd throw away the 3, right? But, you know, we're well on our way to being sophisticated, you know, mathematical people. So we want to use interval notation. So the way that we do that is we describe, you know what this looks like. It looks like this, right? You got this line here, and then here's 3, and we throw it away. So we put a circle there. You got to go this way. You got to go this way, right? So we know that we have 2 pieces. The left piece is from -infinity to 3. The right piece is from 3 to +infinity. I want to write them as intervals. I don't include 3, so I'm going to put a round bracket. And actually, -infinity isn't a real number. It's like an idea. Like that symbol means you just keep going forever. So we actually have to put a round bracket because infinity isn't a real number. We have round brackets on the positive part as well. So if we want to include both of these sets, then we've got to use a U here. U means union. This means union. Okay. So so a lot of times students get union and intersection kind of mixed up. And the way I explain it to my stat students is when you think of union, you know, when 2 people get married, it's like they form a union. So I want you to imagine that, like, you know, one person, they got all this stuff. You know, they got a stereo, they got a microwave, they got a computer, they got a couch, whatever. And then the other person also has a bunch of stuff. They, you know, maybe they have a bike, they have a car, they might also have a couch, they might also have a computer. And then when they get married, what happens? You know, everything gets joined together. So now it's, oh, what do we have as a collective? Well, we now have, you know, some duplicates, but it's sort of like the union is the collection of all of our stuff kind of joined together. Okay, so that's what this set is. So a lot of times when we're describing sets, we need to use this union notation in this class. And we'll use interval notation and this union symbol. Okay.